In this video, we'll look at precipitation reactions. A precipitation reaction is a reaction that yields an insoluble product, precipitate, when two solutions are mixed. Precipitation reactions are a subclass of exchange reactions. To look at this type of reaction, let's just go ahead and start with your average problem. Predict whether mixing an aqueous solution of potassium carbonate with an aqueous solution of barium chloride will result in a precipitate. If so, identify the precipitate. First, let's look at what's given in the question. Well, it tells we're going to be mixing an aqueous solution of potassium carbonate and an aqueous solution of barium chloride. So that's where we'll start. We have potassium carbonate, going to put the symbol AQ behind it to symbolize that it is aqueous, and then the barium chloride. What we have to figure out is what the products are. Now remember, this is a subclass of the exchange reaction. And also remember that these are aqueous. Since they're aqueous, we can consider that the potassium ion and the carbonate ion have been separated by the solvation process, and the barium is separate from the chloride. We often also refer to this as a double displacement reaction. If we think about it, potassium carbonate is held together by its electrostatic attraction. So therefore the potassium will also be attracted to the chloride. The barium can also be attracted to the carbonate, so therefore we have our exchange, resulting in barium carbonate. We are going to need one carbonate for the barium, since the carbonate has a -2 and the barium has a +2. And with potassium chloride would be our other reactant. So let's write this in the equation. So our chemical equation now will be the potassium carbonate and the barium chloride going to barium carbonate and potassium chloride. Now notice that it is not balanced. It's always a good idea to balance your chemical equations. We have 2 chlorines on the reactant side, but only 1 chlorine on the product side. So let's go ahead and put a 2 in front of the potassium chloride. And now if we check, we see that it's actually balanced. To answer the question, we need to figure out whether the barium carbonate and potassium carbonate are soluble. To do that, we're going to look at the guidelines for solubility of ionic compounds in water. These are a set of rules. The first rules focus on solubility. The last 3 rules focus on insolubility. Now some of these rules have an exception, and the exceptions are important. Let's go through the rules, and then we'll figure out which rules pertain to this specific problem. Rule 1. Most salts that contain alkali metals, that's lithium, sodium, potassium, rubidium, and cesium, and ammonium, are soluble. Rule 2. Most salts that contain nitrate anion are soluble. Rule 3. Most salts of anions derived from monocarboxylic acids, such as the acetate ion, are soluble, except for silver acetate and salts of long-chain carboxylates. Rule 4. Most chloride, bromide, and iodide salts are soluble, except salts of metal ions located on the lower right side of the periodic table, such as copper, silver, lead, and mercury 2. The next 3 rules focus on insoluble products. Rule 5. Most salts that contain the hydroxide and sulfide ions are insoluble, except salts of alkali metals, the heavier alkaline earths, and the ammonium ion. Rule 6. Most carbonate and phosphate salts are insoluble, except salts of the alkali metals and ammonium ion. Rule 7. Most sulfate salts that contain main group cations with a charge equal to or greater than +2 are insoluble, except salts of +1 cations, magnesium, and depositive transition metal cations such as nickel. With these guidelines, we can then look at our reaction and see how the barium carbonate and potassium chloride fit into these rules. For barium carbonate, we don't see barium in the list, but we do see carbonate in Rule 6. This is an insoluble. Now, is it part of the exception? No, barium is not part of the exception, so therefore the barium carbonate would be insoluble. We notice that the potassium carbonate that was part of our reactants is soluble and was an exception to Rule 6 because the potassium is an alkali metal, and that makes the carbonate soluble. Let's consider our potassium chloride. Potassium chloride, the potassium fits in Rule 1, the chloride fits in Rule 4. So both by Rule 1 and 4, this product is soluble. So let's look at our chemical equation. Notice here we've added the solid symbol for barium carbonate, since it will be our precipitate, and the aqueous symbol for potassium chloride, since it will be soluble. What was the question asking for? It was asking, is it a precipitation reaction? It is. There is an insoluble product. What is the insoluble product? Barium carbonate. Precipitation reaction problems aren't overly difficult. They do use several previous steps, such as figuring out the compounds and products. All you need to do is use the rules or guidelines to figure out whether something is soluble or insoluble. Practice with precipitation reactions and become confident.